In this lecture, we'll discuss blockchain forks. You may have heard about them in the context of Bitcoin, Ethereum, and other blockchains. The goal is to categorize the types of forks and understand their impact on blockchain networks. In an ideal world, a blockchain is linear, one block after another. In reality, however, blockchains can look a bit more chaotic. Imagine two Bitcoin miners discovering blocks around the same time. At first, neither of the blocks is inherently better. Miners can, and generally will, continue mining on an arbitrary fork, or possibly the one they first spotted. Usually, this scenario will get quickly and organically resolved through a commonly employed longest chain rule. So in short, keep mining on any until one of the forks is longer, and then discard, orphan, the shorter one. This is in fact the simplest flavor of forks, that due to its short-lived nature is called transitory forks. And as a side note, transitory forks aren't exclusive to proof of work. Even in consensus protocols like Babe, which you will learn about later in the Polkadot module, you might see multiple blocks mined in a single slot. Let's look at some other fork types and how they are placed in our fork map. First, we have transitory forks, which are the simplest kind. These are temporary forks, and their existence is often accounted for in the protocol, so they aren't major disruptions. Then there are consensus forks, which are a completely different beast. They arise from differences in the protocol, so how nodes mine, interpret, or validate blocks, before versus after protocol changes. Consensus forks are further divided into hard forks and soft forks, and we will be diving into them in a second. But first, to better understand forks, let's introduce the idea of a validity set. Think of this set as a collection of all possible hypothetical valid blocks that meet specific protocol rules. When a protocol change occurs, the validity set can change as well. Stricter rules can shrink the validity set, and relaxed rules can expand it. Completely different rules might even make the old and new sets completely disjoint. And what happens when there is a difference in validity sets between different versions? That means that some blocks are valid under one set of rules, while invalid under the other. There is a conflict, and this conflict results in a network split, known as a consensus fork.